Okay, so much like multiplying and dividing fractions is arguably easier than adding and subtracting, the same is true about rational functions, because of course when multiplying fractions you just multiply across, and dividing fractions just becomes multiplication. Adding and subtracting is a little trickier in that, for example, if we were doing 1/4 plus 5/6, we would have to get a common denominator, and we only add or subtract across the top, or the numerator of the fraction. By multiplying by some number that equals 1, we can make the denominators the same. Okay, so the common denominator of rational expressions. To find the common denominator of rational expressions, you must find the common denominator of the coefficients, each separate variable. Remember, things like x minus 4 and x are considered different. When something has a number added or subtracted to it, you can't say, well, they both have an x, that must be a common denominator, and just tack on a minus 4. That's not how it works. It has to be something you can multiply by, so the moment adding or subtracting is involved, there are different factors. So let's talk about what happens if we have 1 over x plus 1 over x plus 4. They don't have a common factor, and the common denominator is going to need the lowest or the highest power of each one, x and x plus 4 that you see. Both of those are to the first power, so our common denominator here is an x and an x plus 4. So what does that mean? It means that the first one, 1 over x, is missing the x plus 4. Which means we have to multiply the first fraction by x plus 4 over x plus 4. The second fraction, 1 over x plus 4, is missing the x, so we need to multiply by x over x. What that means is when we do this, we have to use our multiplication from 6.2. 1 times x plus 4 over x times x plus 4. 1 times anything is just itself, so it's x plus 4 over x times x plus 4. 1 over x plus 4 times x over x for the second fraction. It's just x over x times x plus 4. You'll notice here, once I do that, I have a common denominator, x times x plus 4. Now this is like 1/5. 1/5 plus 2/5 is 3/5. From here, we just add across the numerator, so x plus 4 plus x. It's really 2x plus 4, divided by our common denominator of x times x plus 4. Now, you could multiply out that x times x plus 4 if you wanted to, but here it's usually just smarter to not mess with that too much. You could also factor out the 2 here to check if there are any other factors, but for now, it's fine. Just remember that sometimes you end up having to clean up or have to do another operation afterwards, so this is why you might want to hold off on multiplying it out. But this is also the same as 2x plus 4 over x squared plus 4x. Now one thing to note, 2x plus 4 and x plus 4 can't cancel out. They're not the same thing. And you can't see this part and this and cancel out. Don't cancel those out. Don't do that. 2x plus 4 and x plus 4 are different things. Don't cancel out parts. Don't cancel out the 4's. That 4 is paired with an x. Don't cancel out anything in this regard. Okay, so let's look at some problems and see what we can do. At first, we're just going to practice by finding the common denominator before we do anything. So the common denominator between 14, 10, and 70. I sometimes think the easiest way to do common denominators with numbers is to draw your trees. 14 is 2 times 7, 10 is 2 times 5, 70 is 2 times 5, or 2 times 35, which is 5 times 7. So just like I argued for variables, we need at least 1, 2, because everything has 1, 2. We need 1, 5. We need at least 1, 7, which is 2 times 5 times 7 is 70. 10 and 14 already go into 70, so your common denominator is just 70 here. What about 13 over 10x to the 5th and 11 over 98x to the 8th? Well, our common denominator for 10 is 2 times 5. 98 is 2 times 49, which is 7 times 7. So from the number side, my common denominator needs a 2. It needs a 5, because one of them has a 5. And it also needs 2 7s, because one of them has 2 7s. So this ends up being 490. For your variables, When you see the x's, it's just whichever one, the most of that variable you see is how many you have to have. So that means for variables, which one has more? The x to the 8th. So I need x to the 8th. So in total, the common denominator is 490 x to the 8th. With numbers and variables in binomials, it's a little different. In this first one, I'm going to factor 5 times x plus 1. The second one, I'm going to factor out the negative 7 times x plus 1. I'm just going to move the negative 7 to the numerator, make this 2 over 5 times x plus 1, and negative 5 over 7 times x plus 1. The negative can always be shifted around. I would recommend doing so when in doubt. So from the number perspective, same argument. The numbers that are multiplied, I need a 5 and a 7. But I also need this x plus 1. So in total, my common denominator is 35 times x plus 1. Or you can leave it like this so it's more clear in that regard. Lastly, let's look at 4. What are my denominators here? If I factor out the y here, this is y times y plus 7. If I factor this thing, I'm looking for two numbers that multiply to negative 21, add to 4. That would be 7 and negative 3. This factors into y plus 7 and y minus 3. So what do I need in my common denominator? I need anything that's in the denominator of any of these fractions. So there's no numbers like the other ones. So there's at least a y, at least one y by itself. Both of them have a y plus 7, so I'm definitely going to need that. This one also has a y minus 3. So my common denominator is going to require all of those factors. So that's something to keep in mind. And we will do one more on the next page. Five over p squared plus 8p plus 15, 5 over p squared minus 3p minus 18, and 5 over p squared minus p minus 30. We have to factor all of these denominators. So two numbers that multiply to 15 that add to 8. It's 5 and 3. So this factors into p plus 3, p plus 5. Two numbers that multiply to negative 18 that add to negative 3 should be negative 6 and positive 3. Numbers that multiply to negative 30 that add to negative 1, that's p minus 6 and p plus 5. So it's my common denominator. I need at least one p plus 3, which handles both of those p plus 3s. I need one p minus 6. And I need one p plus 5. And once you know it, those three multiplied together covers all of the denominator. And so that would be my common denominator. So if I were making my fractions all have a common denominator, this first fraction has the p plus 3 and it has the p plus 5, but it's missing the p minus 6. So I would have to multiply the numerator and denominator by p minus 6. The second fraction is missing the p plus 5, but it has the p minus 6 and p plus 3, so I'd have to multiply by the p plus 5 in the numerator and denominator to get this to have all three. And the third fraction has the p minus 6 and p plus 5, but it's missing the p plus 3, so I would have to, again, multiply the numerator and denominator by what's missing, the p plus 3, and then they would all have a common denominator. Their numerators would change, but at least that would allow me to combine them. So we'll do some actual adding and subtracting problems in the next video.